So we've talked about climate. Now we're going to talk a little bit about just some basic weather. And I'm sure everyone has heard on the weather report a high pressure system is coming into the area. And so now we're just going to kind of go over what that means. And at this point, this should all sound very familiar to you. But just to review, in a low pressure system, you end up with kind of rainy, not very nice weather. Whereas in a high pressure system, you end up with a really nice, crisp, and fair weather over an area. And so, just like we were talking about in our convection cells, a low pressure system um, has low density. And so it causes that center of the air mass to rise. And as it's rising, it cools down. And as it cools down, it starts to condense. And as it's condensing, it's forming clouds. And all of the clouds are building up, building up, building up moisture. And ultimately, it can't hold it anymore. And voila, you have precipitation. Whereas in a high pressure system, you have this cool, dense air um, that it's dropping down towards the surface of the earth. And as long as that air mass is there, you'll have very nice weather. What is not so nice are monsoons. And so this happens a lot in India, but here in the northeastern United States, we definitely do not get this. But monsoons are very, very heavy rainfalls experienced by a continent or an area of land that's lying north or south of warm oceans. So usually it's equatorial because you need extreme intense heating happening on the land. And so it's kind of like an extreme sea breeze that's happening. Um, so you have a very, very strong heating of the land surface. It gets very, very hot, very intense. And so that air mass is rising, and that that sea breeze or the ocean is coming in from there. And so because this is so hot, it condenses very, very fast as it cools down as it's rising, and it ends up raining a lot over the surface of this area of land. And so here is a little video to explain the monsoons in India. You can go into our shared drive and watch this video if you'd like to know more about monsoons. But I am going to move forward, so no video within a video. So cities also have their own little climates. And so this is really an anthropogenic climate that we've created here. And so cities have building materials such as bricks, concrete, asphalt, right? They are all surfaces that absorb heat. So they have a very low albedo, and they not only do they absorb the heat, they really hold on to that heat. And what we end up getting is kind of something called the heat island effect. And so we have an island of heat only in the cities. If you were going to go right outside of the cities, where maybe it's not so populated and not so completely covered by impervious surface or dark surfaces, so a lot more natural cover, you end up with a much lower temperature. So we are actually causing the temperature to rise within the areas where we have all of these building materials. Not only that, buildings also block a lot of wind flow, so you end up without that um, convective effect of the wind that will take away some heat from the land. And so not only that, we also have motor vehicles, cars, buses, um, that release a lot of heat and pollutants as well. And so that is all contributing to this microclimate that's happening within the city. And so all of this leads to haze, smog, depending on where you are, um, higher temperatures, lower wind speeds, and so obviously this is changing the climate quite a bit. There are a couple of things that we'll talk about in the future about how we can reduce these effects. So, for example, if you look at a building like this, with these nice flat tops, what people are doing now is they're building green roofs. So number one, it's taking in a lot of water, so it's reducing the runoff that comes from cities. And number two, it's reducing the amount of heat that's absorbed. So a green roof can actually reduce the increase in temperature in a city. Pretty cool. And another kind of weather are tornadoes. And so we're not going to go into the super detail about how tornadoes form, but pretty much it's a mass of very warm air meeting a mass of very cold air. And this kind of shock ends up causing the warm airs to rise really quickly, creating a very powerful current. And if it rises just right in the right circumstances, you ended up with this like spinning funnel, and the middle has a low pressure center. And so, as you guys may or may not know, right, that is a tornado is spinning wind, spinning air, and you can get wind speeds up to 300 miles per hour. And they're rated F1 through F5, F5 being the largest. So, yeah, pretty destructive if it gets up that high. And here is a video. Again, I'm not going to show it, but if you're very interested, please go ahead and do watch on your own. And finally, we're going to talk about hurricanes. And hurricanes, typhoons, cyclones, they're all exactly the same. The only thing is where they occur. And so it forms when warm, moist air is over very warm oceans. And so the winds end up rushing into areas of low pressure, and you get this counterclockwise motion of wind in the northern hemisphere. In the southern hemisphere, it would be a clockwise. And so these convective currents are drawing up very, very large amounts of water vapor, and that's why we end up getting very, very heavy rain. And so here is a hyperlink to a PDF or an article about the environmental effects of hurricanes on marine habitats. It's very informative, and I highly suggest that you go into our shared drive and take a look at it.